Today, we will be talking about parallel lines and proportional parts.
Triangle proportionality theorem, Theorem 7.5. If a line is parallel to one side of a triangle and intersects the other sides, then it divides the sides into segments of proportional lengths. Here's a quick example of this theorem. If BE is parallel to CD, then AB over BC equals AE over ED. I'll break that down. If BE, this segment right here, is parallel to CD, that means that AB, right here, over BC equals AE over ED.
Let's solve this problem using the triangle proportionality theorem. In triangle KEL, segment HA is parallel to EL. If KA is equal to 3, AL is equal to 1.5, HE is equal to 1, find KH. Using the triangle proportionality theorem, segment KH over HE is equal to KA over AL. When substituting the numbers in, you will get segment KH over 1 is equal to 3 over 1.5. Using the cross product property, KH times 1.5 is equal to 3. Then you multiply KH times 1.5 and you get 1.5 KH is equal to 3. When you divide each side by 1.5, you get KH is equal to 1.5 in length.
Let's learn about Theorem 7.6, converse of triangle proportionality theorem.
If a line intersects two sides of a triangle, like segment ED, and separates the sides into proportional corresponding segments, then the line is parallel to the third side of a triangle. For example, if AE over EB is equal to CD over DB, then AC is parallel to ED.
Here's an example of the converse theorem. In triangle AEC, segment ED is equal to 3, DC is equal to 9, and segment AB is 1/3 the length of BC. The question is segment AE parallel to BD? To show that you're parallel, you must show that AB over BC is equal to ED over DC. These parts have to be parallel. AB over BC is equal to ED over DC if the statement of AE is parallel to BD. To do this, we must find each ratio. Say AB is equal to X. Since in the given information, AB is 1/3 the length of BC, then BC must be 3X. AB over BC, when you substitute the numbers in, X is X over 3X. You cancel out the X's, and AB over BC is equal to 1/3. Using the numbers in the given up here, ED over DC is equal to 3 over 9, which is also simplified to 1/3. Since both of the segments are 1/3, therefore AE is definitely parallel to BD.
For a real-life problem of the converse of triangle proportionality theorem, let's go to Pizza King. Let's use the converse of triangle proportionality theorem to find out if this French fry line is parallel to the pizza crust. So I drew a picture of the pizza. Here's the pizza crust, and here are the French fries. We found the lengths of these segments by measuring the pizza itself. The segment from the tip of the pizza to the French fries was 6 inches on both sides, and the measure from the bottom of the French fries to the crust was 3 inches on both sides. Now let's figure out this problem. If AB over BC is equal to AE over ED, then that means that BC is parallel to ED, which would mean that the French fries are parallel to the crust. I plugged the measurements into the formula So AB is 6 inches, BC is 3 inches, which is equal to AE, which is also 6 inches, and ED, which is also 3 inches. That's 6 over 3 equals 6 over 3 simplifies to 2 equals 2. And 2 and 2 are equal to each other, so that means that BC is parallel to ED. The french fries are parallel to the crust.